This is the miracle of being able to see what was not being able to see before.
It's more like Star Trek, right? It's the age of exploration again.
It's simply incredible. So we biologists like to see how things occur, and we like to see a cell, we like to see the interior of a cell.
Cells didn't evolve on a cover slip. Cells didn't evolve in isolation, right? So we want to be able to study these cells in a more natural, more physiological setting. Lights will be flashing again.
Eric Betzik, which is the inventor of this microscope, had two brilliant thoughts. One was to create a form of microscopy where you have a very thin layer of light that you scan through the sample, and that allows you to minimize the damage in the samples. And the second problem that he found a solution for is he borrowed a trick that the astronomers use today with their telescopes, which is how you deblur the perturbations you get on the atmosphere when you're looking at a star. And we have the same problem when we're looking inside a tissue.
With this microscope, for the first time, you can actually observe subcellular details at an unprecedented level.
I started to work on how cells eat for many years. All my life I dreamed to see this happening in a live organism. Finally, we have been able to do this.
Being able to observe a neutrophil just crawling through the ear of the zebrafish, scooping up all of these food particles that we've injected, that's just mind-blowing. I actually got goosebumps in my hair. I still have goosebumps thinking about the moment when we actually first saw that. Being able to visualize that was phenomenal.
Cancer cells. So these are human cancer cells that have been implanted in the zebrafish. And you can see now the cells moving along capillaries, cells crossing the wall of the capillaries. But it's not just a blob of the cell like other people have seen in the past. This time we see the details of how the cell is sending pieces of the cell to explore their space.
We've mapped the entire eye of the zebrafish and then computationally exploded the cells such that you can look at each cell as a unit. And what you can actually observe is the changes in morphology in the context of the tissue. That's never been done before. You can look at how all of the intercellular compartments are dynamically changing. Right? We can see cell mitosis, cell division, cells kind of pushing against, beating up their neighbors while they're kind of violently dividing. Or at least that's the impression I get when I'm looking at the cell divisions.
Now I cannot sleep anymore. I'm up every night trying to figure out how to do the next thing. That's
like one of the highlights of working at the forefront, is because you're one of the first people to see these things. You're the first person to see this even before your boss gets to see it. So that's amazing.
Up to now, the science that we have been doing is hypothesis testing. Now we can do hypothesis generating.
If it were up to me, I would spend the next couple of years just imaging and exploring, because I feel like there's a lot of unknowns. You can actually start to ask questions that can push the frontiers in new directions.
And then we can generate our thoughts on how to go next and test. That's a big, big difference.